Friends, when we talk about sulfur in transformer oil, most people jump straight to DBDS. But DBDS is not the first warning. Before corrosive sulfur attacks copper, before copper sulfide forms, there are early sulfur indicators hiding in oil. Hydrogen sulfide, H2S Mercaptans, R-SH. These compounds are volatile, reactive, and often appear before severe corrosion risk is confirmed. In today's Electroverse episode, we decode H2S and total mercaptan sulfur. What H2S really indicates in transformer oil, what R-SH mercaptans represent chemically, IEC and ASTM test methods used, why standards avoid fixed alarm limits, how these tests support corrosive sulfur assessment, and how senior engineers use them as early screening tools. Stay till the end, because H2S and R-SH whisper the problem before DBDS shouts it.
In our previous discussions about corrosive sulfur and DBDS, we explored how compounds can silently destroy power transformers. But sulfur risk does not end there. Today we talk about two silent precursors that often go unnoticed until it's too late: hydrogen sulfide or H2S and total mercaptans known as R-SH. These gases tell us whether sulfur chemistry is active, unstable, and dangerous. Think of H2S and mercaptans as the early warning system for sulfur attacks. While DBDS shows us known corrosive sulfur that has already formed, these compounds reveal something far more critical. They show us sulfur chemistry in action. They are the difference between seeing the damage and preventing it. Now let me explain why these compounds demand our immediate attention. H2S is a highly reactive sulfur gas that behaves very differently from DBDS. Unlike DBDS, which can remain stable in oil for months, H2S does not stay long in oil. It reacts fast, and that makes it dangerous. The moment H2S forms in transformer oil, it aggressively attacks copper surfaces and accelerates copper sulfide formation. Here's what makes H2S particularly concerning. Its presence means copper attack may already be happening, or conditions are ideal for it to start. When we detect H2S in transformer oil, we're not looking at a potential future problem. We're looking at active sulfur chemistry that's happening right now. The testing for H2S follows guidelines referenced in IEC 6422, which provides maintenance guidance for mineral insulating oils. The latest edition from 2024 emphasizes the importance of comprehensive oil monitoring, including sulfur compound analysis. What's critical to understand is that there is no acceptable limit for H2S. Any detection, even trace amounts, is abnormal and requires immediate investigation. Now let's talk about mercaptans. These are organic sulfur compounds with the chemical formula R-SH, where R represents an organic group. Think of mercaptans as fuel for sulfur reactions. They are less aggressive than DBDS initially, but they are chemically unstable and capable of converting into corrosive sulfur forms under the right conditions. Mercaptans testing commonly aligns with ASTM D3227 standards, which covers the determination of mercaptan sulfur in petroleum products. While this standard was originally developed for fuels, the principles apply to transformer oil analysis as well. The key difference is that mercaptans are interpreted by trend and correlation, not absolute ppm alone. Here's how we interpret these compounds in real field conditions. When we find elevated mercaptans, especially with increasing trends, it indicates active sulfur chemistry and increased risk. This risk becomes even more pronounced with temperature and aging. The mercaptans act as precursors, ready to transform into more aggressive sulfur compounds when conditions change. Let me walk you through the engineering interpretation that every transformer engineer should understand. When we detect H2S at any level, this is abnormal. There's no debate here. Investigate immediately. When we see elevated mercaptans with increasing trends, this indicates sulfur potential even if DBDS levels appear low. This is your preventive action window. But here's the critical scenario that demands red alert status. When we detect H2S, particularly with R-SH present or a history of corrosive sulfur, this indicates active sulfur reactions. This means high probability of copper sulfide formation and sudden failure risk. This is not a watch and wait situation.
Some transformers failed because DBDS was low, but H2S was ignored and sulfur chemistry was active. This teaches us a crucial lesson. We cannot rely on DBDS alone. The sulfur risk assessment requires all three parameters working together. When we encounter high H2S or elevated R-SH levels, immediate engineering actions are required. First, correlate with other sulfur tests including DBDS and dissolved gas analysis. Second, Assess transformer criticality and design vulnerability. Third, plan for oil replacement or transformer replacement based on the severity and operational importance. It's important to understand that filtration is ineffective at removing sulfur compounds. These are dissolved chemical species, not particles that can be filtered out. Passivators like BTA can offer only temporary mitigation, but they don't address the root cause of active sulfur chemistry. Here's the field reality that every engineer must grasp. DBDS shows known corrosive sulfur, Mercaptans show sulfur potential, and H2S shows active sulfur attack. Together they complete the sulfur risk assessment triangle. You need all three to make informed decisions about transformer health. The industry has learned hard lessons about sulfur chemistry. Utility oil sulfur screening practices now emphasize the importance of comprehensive testing that includes H2S and Mercaptans alongside traditional DBDS analysis. This comprehensive approach follows IEC 6422 practices for proper oil condition assessment. H2S is a red alert parameter, not a watch and wait parameter. When you see it, act immediately. The chemistry is already active and time is not on your side. Respect sulfur chemistry, it never wants twice. By the time you see significant DBDS formation, the damage may already be irreversible. Understanding H2S and Mercaptans gives us the power to prevent sulfur-related failures before they happen. These compounds are our early warning system, telling us when sulfur chemistry is becoming active and dangerous. Use this knowledge wisely, and you can save transformers that might otherwise fail without warning.
So friends, this is the real meaning of H2S and Mercaptans in transformer oil. These tests do not replace corrosive sulfur testing. They support it. H2S indicates active sulfur chemistry. Mercaptans indicate reactive sulfur compounds. Remember these rules forever. Healthy oil. H2S absent or negligible. Rising R-SH, reactive sulfur activity. Increasing positive sulfur indicators. Deeper investigation required. There are no universal limits in standards because sulfur behavior depends on oil chemistry, temperature, and materials. That's why these tests are screening tools, trend-based, and risk indicators, not pass-fail decisions. If this explanation helped you understand early sulfur risk detection, support Electroverse. Like this video, comment below. Do you see H2S or R-SH reported in your oil analysis? Subscribe, because next we connect H2S plus R-SH plus DBDS plus IEC 62535 into one sulfur risk logic. You've been watching Electroverse, where every spark tells a story. Stay charged, stay safe, and happy.